The homework assignments, anything you all would like to have done at this time? Anything you want to go over? No, everything is clear. Number 6. 6, 7, right, we're getting some coming out now. 4, right, good, okay, good. Let's see what we're coming up with now. Okay, first person, somebody said number 6. Let me see. You have the question? 6 here. All right. Number 6 said the ingredients for a cake, which will serve 12 people are as follows: 55 grams of butter, 110 grams of caster sugar, 6 egg yolks, 120 grams plain flour, and 3 tablespoons of milk. What quantities are needed to serve 4 people? Okay. In this case, is a simple relationship you're looking at. 12 people require all of these amounts, right? 12 people require all of these amounts. If this would be a direct proportion situation, right? Meaning, if the number of people go down, the amount of eggs and so on required to feed those people should also go down. Good? And what is the fraction of 4 relative to 12? That's basically what we're saying. Okay? So we could break it up into the scenario that we had spoken about, where if we let X represent the number of people, right? Number of people you're making the cake for, and Y represents the amount per ingredient, whatever the ingredient may be, right? We know that this is a direct proportional relationship between the number of people and the ingredients that will be used, right? So we said X would represent the people that are being fed, and Y would represent the amount of the ingredient, amount or quantity, whatever measure they're using, quantity of the particular ingredient. Okay? So if we look at X1 and X2, Y1 and Y2, right? Let us see, in this case, X1 would be the first amount of people they mentioned, which was 12. So X1 would be 12. X2 is the second among the people they mentioned, 4. Okay? What else? Y1 would be the first among the ingredient they mentioned. In this case, if we look at 55 grams of butter, looking at the ingredient butter, right? Y1 will be 55. That's because that's the first amount of butter they spoke about, referring back to the 12 people. So what would happen for the 4 people in terms of butter, right? This was for butter. This would be the unknown quantity, right? And we learned that the relationship between 2 quantities that are in direct proportion what's the equation you learned? Right, very good. X1 over Y1 is equal to X2 over Y2. So if I write it down, X1 over Y1 is equal to X2 over Y2. That's the relationship we learned. Okay? So we just put that information in there. X1 will be 12 over Y1 will be 55. And that's equal to X2, which is 4 over Y2, which will be unknown. Right? And then you could solve that relationship by doing your normal cross multiplication and solving. So you could say 4 by 55 would be equal to 12y2. What I did, I cross multiplied. I said 4 multiplied by 55, top by bottom, is equal to 12 by y2, top by bottom again. That's how we do cross multiplication. And then we could work out what y2 is by dividing the right-hand side by 12. So we'll get y2 if we divide that side by 12. And we know we must also divide the left-hand side by 12 as well if we want to solve that equation properly. If you work out that, what will you get? What will you get? 18.3. Right. 18.3. That's what I said, 18.3. Right, so that'll be 18.3. And the answer there, unit was initially 55 grams. So the answer down here will also be 18.3 grams. Now, for each of the others, all we're going to do is recognize that what is going to be consistent. The 4 is always going to be there. The 12 is always going to be there. It's just this quantity here is what will be changing each time for each ingredient. Correct? So as you go down the road or the line, you'll see 110 grams of castor sugar. So you'll just put 110 where the 55 was. And you work that out. And you keep doing that for each ingredient and you'll get the answer. Okay? Now, there are a lot of other ways that you could approach this. This is not the only way. It is just a format that I put here for you that you could represent it mathematically line by line. Okay? Instead of writing something out of the air. Because somebody might have said, well, you could have just put 4 over 12 and multiplied by the number of ingredients. Yes, you could, but what is your logic? What is your statement? You understand? You must have something to show, well, what is going on here. As a matter of fact, what should be written before this equation is this line. This is direct proportion. That's actually what we should put before we write the equation. Then you write therefore, and you write it down what equation you're going to use. Okay? Any question on that one? Okay, so you could take it down. If you don't have it, you could take it down if you need to. Okay, starting off at 7. 7 says 4. In what length of time will $16 be the simple interest on $480 invested at 8% per annum, right? Number 4. In what length of time will $16 be the simple interest on $480 invested at 8% per annum? Let us identify what we have there. In what length of time will $16 be? That tells me that the principal in this question is $16, right? Because you're interested in what that will be. Sorry, will $16 be the simple interest? So that'll be the simple interest, not the principal. So this is wrong. The simple interest will be $16. 480 is what is invested. So the principal will be equal to $480 at 8% per annum. So that means that the rate percent per annum is 8%. Okay? That's what it's supposed to be. And they're asking in what length of time. So they want you to find what T is. That's the question. What is T? So we're going to use the equation simple interest I is equal to principal by rate by time divided by 100. So all we have to do is substitute in here and solve for the unknown. The interest is $16. I won't put any dollar sign just yet. The principal is $480. The rate is 8. The time is unknown. And you divide that by 100. Okay? So now we have to solve for t. T is the unknown. So all you do, 16 will be equal to, you work out 480 by 8 divided by 100. What does that work out to be? How much? $38.4. So 16 is equal to 38.4 multiplied by t. Okay? So 16 over 38.4 will be equal to t. And that worked out to be 0.42 years. Was that the answer in the book? Huh? Check it and see, no? Huh? 5 months. Okay, 0.42 years. How many months in a year? 12? So if you multiply by 12, you'll get the 5 months. Remember, this answer is in years. And I actually rounded it off to the nearest year. The second decimal place. But really, it was really 0.41666 recurring going down the line. So if you multiply that, as a matter of fact, if you take the 16 divided by 38.4 and multiply by 12 to get it in months, you'll probably get the exact 5. Let me try it now. 16 divided by 38.4 multiplied by 12, you get exactly 5 months. Okay? So there's a good example of when you round off in decimals, you tend to get errors at the end, or you have to round it off as well. So the exact answer will be 5 years. So a better approach, instead of writing 0.42 years, that if that's rounded off, you could write 16 over 38.4 multiplied by 12, and that answer will be in months. Okay, whereas that answer was a rounded off answer in years. If we took this, this is the time, but we converted to months by multiplying by 12, what would happen? This would work out to be the exact answer that they have in the back of the book, which is 5 months exactly, which is what you're looking at. Any question? Good so far? All right, so take it quickly. Okay, 7 says the interest on $200 invested for 4 months is $6. So right there I could write that the interest is $6. The interest on $200, that tells me that the principal is $200. And the time is 4 months. But remember, in these questions, time is not in months, it is in years. So I'd have to convert the 4 months to years by saying 4 over 12 years. 4 over 12 years is really a third of a year. Because 4 into 4 is 1, 4 into 12 is 3. So therefore, what are they asking me? What is the rate percent? So the rate percent is the unknown factor. So we write of course, that simple interest is equal to principal by rate by time all over 100. So based on that equation, we could say that I, which is $6, is equal to the principal, which is $200, multiplied by the rate, which is unknown, multiplied by the time, which we know is a third of an year, over 100. So what we're going to do next is we'll evaluate what 200 divided by 100 times a third is, right? And we could probably even see it here, right? So that'll be 2 multiplied by a third, which is 2/3. So $6 is equal to 2/3 R. Okay, and if I want to get what R is, all I have to do is divide this side by 2/3, right? And I'll take it out. And therefore I have to divide this side by 2/3, not so? So this side will be 6 divided by 2/3. And if I divide this side by 2/3, I'll get what R is. Is that correct? So all you have to do is punch in 6 divided by 2/3 on your calculator, and you'll get what the rate percent is. You may not know how to do 2/3 on your calculator. So, sorry? You get 9, right? But the button you'd use is A and B over C. There's a button on the calculator that has A and B over C. So you'd punch in 6 divided by 2. You press the button A and B over C, and then 3. And you'll get an answer of 9. The answer here is 9, and it will be 9%. Okay, so the answer for number 7 is 9%. All right, it's useful to know how to punch in this on your calculator. If anybody has any challenges with that, you could talk to me and I'll show you how to do it afterwards. After 7, what is the next question after 7? 11. 10? I better do all. 9 as well? Okay, we do 9 after 7. Okay, number 9, they said, which receives the more interest per annum? 150 invested at 4% or 180 invested at 3.5%? What is the annual difference? Okay. In the first instance, let us call the interest you receive in the first one I1, right? So I1, which is the interest in the first case, will be the first principal that they spoke about, which is $150. The rate of investment was 4%. And the time for that investment was 1 year, because it's a per annum. You divide that by 100, and you'd get the interest I1. Okay? When you work out that, what do you get? 6? 6, okay. So the interest would be $6. That is I1. The second case, which we'll call I2, the principal that he invested there was 180. By the rate in this case was 3.5%. And again, the time is 1 year. If you divide that by 100 to get the interest. And when you work that out, how much you got? 630. Okay, so $6.30. So definitely you could see that in the second instance, right, that would be the greater interest. Right, so second interest, I2 would be the greater interest. Therefore, I2 is greater. what is the annual difference? And the annual difference, of course, will be $6.30 take away 6. And that will be equal to 30 cents. Okay? Simple as that. That was number 9. I feel what was given trouble is just what the English meant. Was the translation in English, right? Even though I read in English, he wasn't too sure what it meant. The next one in line after that was what? 10? You all want 10 done? All right. Okay, number 10 is very similar to number 9. Right? Number 10 is very similar to number 9. Because in number 10, they give you the same thing. They give you the principal and the interest again. So you go through the same calculation, and then you just add the two interests together. Okay? Is it that when you check the answer, it wasn't adding up as what they had in the back, and you wanted to double check it or something? Okay. So I'll just quickly calculate it for you and make sure that you have it. So in that case, I1 was $700 principal by the rate, which is 6%, by the time, which is 1, over 100. And I2 would have been $300 by 8%. 300 by 8% by 1 year over 100. Okay? That, in the first case, that works out to be how much? $42. And the second case, that works out to be $24. So therefore, the total interest, which is I1 plus I2, will be equal to $66. Right? Is that different to what the book had? No? Okay, so it was easy. Wasn't hard, right? $66 was the answer for that one. Okay, what's the next one? 11? You all had trouble with 11 as well? And not here? Yes? Yes? Alright. Okay, so we'll do 11 now. A man deposited $350 in a bank, and $14 interest was added at the end of the first year. The whole amount was left in the bank for a second year at the same rate of interest. Find the amount of interest on the $364 paid in the second year. So you have to figure out, first of all, what the rate of interest is, right, in the first year. And then you would apply that same rate in the second year. So what you do, you write down your equation, interest equal to principal by rate by time over 100. His principal, in this case, was $350. In the first part of the investment, it was $350. And he got an interest on that of $14. So, if he invested this for time of 1 year, then let us calculate what the rate percent per year or per annum was. By using our simple interest equation, we could write $14 is equal to the principal, 350, by the rate, which is unknown, by the time, which is 1 year, over 100. So we are saying, therefore, that $14 is equal to 3.5 R. Right? If you multiply 350 by 1 and divide by 100, you'll get 3.5. Therefore, 14 over 3.5 will give us what the rate is. Okay? And what's 14 divided by 3.5? 4? Okay. So the rate percent per annum is 4%. That's your rate. And that's the same rate you're going to apply on the new amount. Right? The new amount is $364 because you added the 350 and the 14 to give you the new amount that you invested. And therefore, they're asking you to find the amount of interest on that 364. So interest now, we just use back the new interest, we just use back the formula. The principal will now be $364 by the rate which we calculated to be 4%. By the time, 1 year again, because they say let's see what it is at the end of the second year, over 100. And that will give you the answer that you're interested in. 364 by 4 over 100. And you get $14.56 in that case. $14.56. Any questions there? That's okay? $14.56. Okay, don't worry about number 12, right? You don't have to be worried about that one. Come in. Okay, in exercise 33, right, there's a question that deals with two gear wheels. It says 2 gear wheels mesh together. One has 40 teeth and the other 25 teeth. If the larger wheel makes 100 revolutions per minute, how many revolutions per minute does the smaller wheel make? Right? Now, we didn't do any examples like that one, so this is an important one. From the point of view that is something that you didn't encounter as yet. Okay, so let us think about it. They're talking about number of teeth, so I'll call that N for number of teeth. And they're talking about revolutions per minute, so I'll call that R. Okay? Now, initially, they told us the first gear they're looking at, one has 40 teeth, and the other gear has 25 teeth. So I'll call this one N1, number of teeth of the first gear, and the second gear, I'll call that N2. Okay? Now, the number of revolutions per minute made by the larger wheel, which is the one with the 40 teeth, would be 100 revs per minute. So I'll put that here, 100 RPM. It's called revs per minute. Okay? What they're asking us to find is what is the number of revolutions per minute that the 25 teeth would make, and we call that R2. Okay? So what you have to ask yourself, is this direct proportion or is this indirect proportion? That's the first question. Do you know? No, it's indirect because it's in the indirect section, right? But why is it indirect? Because what you would expect is that if the number of teeth goes down, then the revolutions per minute would go up. Right? But why is that so? Just practically, if this gear is meshing with this one, let's say even by a chain. If I use a chain to mesh the gears, So this is one gear here, and this is a smaller gear here. And there's a chain running over this one and around this one. Okay? Every time this makes one revolution, one rev, in your estimation, should this one make more than one rev or less than one rev? Huh? More, because look how big this is. When it turns, it's going to make that one turn a lot more. Every time this goes through one circumference, this is going to go through many circumference of its own, right? Because it's smaller. So what they're saying is that the smaller or the less the number of teeth, the smaller the gear or the less the number of teeth, the more revolutions. Not so? So as the number of teeth goes down, the number of revolutions goes up. And therefore, that's why this is inverse or indirect proportion. And once you know that, then you could apply your formula. And the formula for indirect proportion is N1 R1 is equal to N2 R2. Where does that come from? That comes from X1 Y1 equal to X2 Y2. That's what we learned for indirect proportion. Remember that equation? So we apply it in this case. That X will be the same thing as N, or the number of teeth, and Y will be the same thing as R, or the number of revolutions per minute. Good? So all we have to do is substitute in here and we solve the equation. So N1 is 40. R1 is 100, because this is the first R they spoke about. Let me write it here. Right? So R1 will be 100 revs per minute, is equal to N2, which is 25, multiplied by R2, which is unknown. So therefore, how do we solve for that? We simply say 40 multiplied by 100 divided by 25. We divide by 25 on both sides. That'll be equal to R2. If you work out that, how much do you get? 160 revolutions per minute. And that makes sense, because if this big one is going around 100 times, this is going to go wrong more times because it's smaller. So every time this goes wrong one, that goes wrong more than one. If this goes around 100 times, it'll actually go wrong 160 times in 1 minute. Okay? So that was an interesting question, and this is how we would do it. 160 RPM is the answer for that one. Okay? That's clear for you? Okay. All right, I think so. We should be fairly okay with the questions now. Whose one is this? Okay, one thing we didn't consider in the previous class, we did simple interest, but we didn't do compound interest, right? We bypassed that. So before we go on any further in percentages and so on, let us quickly review compound interest and what it's about. Okay, now the best way to do compound interest, right, is by looking at two ways. There are two ways we could do it. All right, and you could write down this question, and we do this in basic way, and then we'll do one with more advanced formula, with a more advanced formula. Okay, and the question says, a man invests $10,000. A man invests $10,000 at 10% compound interest. For 2 years. A man invests $10,000 at 10% compound interest for 2 years. What is A, the interest earned in each year? what is A? The interest earned in each year. B, the total interest earned. B, the total interest earned. C, the amount accrued after 2 years. C, the amount accrued after 2 years. Okay, in this case, we are dealing with compound interest. All right? And it means that he has a principal of $10,000. And we know that his rate of interest is 10% per annum. So let us go through on a yearly basis what is happening with this money. Right? Now we know our interest formula for simple interest is principal by rate by time over 100. So therefore, in the first year, let us find what his interest is going to be. Right? It's just 1 year, and you have to use this formula because there's no compounding as yet. So we have to calculate what his first year's interest. And let's call the first year's interest I1, right? Which is the interest after 1 year. I1, which is equal to interest earned in first year, right? That will be his principal, which is 10,000, by his rate, which is 10%, by time, which is 1 year, over 100. Right? That's how much he'd earn in the first year. Principal by rate by time over 100. How much does that work out to be? That will be $1,000. Okay, so that'll be the interest he would earn in his first year. Now, in compound interest, in order to determine the interest he would earn in the second year, you have to add the interest he earned in the first year to the principal. And that will be the new principal to be used in the second year's interest calculation. Okay? In other words, when he goes back to the bank after 1 year, the bank will have $1,000 more for him, not so? So his new principal will be 1,000 plus the principal he had put in at the beginning. So let us say his principal now, at the end of the first year, which would be the same thing as the principal at the beginning of the second year. Okay? The principal at the end of the first year is equal to the principal at the beginning of the second year, and that will be equal to the principal he started off with, which is the $10,000, plus the interest he earned in the first year. That will be equal to a total of $11,000. Right? Now the bank, because they're given compound interest, they're going to have to use this principal now in the calculation of the interest for the second year. So let us find I2. What is I2? I2 will be the interest earned in the second year. I2, which is the interest earned in second year, we use the same principal by rate by time over 100 equation, but we have a new principal. The new principal will be this one here. The principal in this case will be $11,000. The rate is still 10%. It's just that it's a compounding situation. By the time, 1 year again, all over 100. That works out to be $1,100. So you notice, unlike simple interest calculation, in compound interest, the interest keeps going up. Right? If I did it for a third year, I'd have to add back the 1,100 onto the 11,000 and then find the interest on that again at 10%. So you notice in compound interest, the interest keeps going up every year. So let us answer the question. They said, what is A, the interest earned in each year? You see the interest earned in each year, that's stated here. So this really is A. We would have been answering A at this point. Right? I1 was $1,000, so that will give me one answer. And I2 will be $1,100. That gives me another answer. Okay? Part B, the total interest earned. That's easy. Total interest earned for part B will be I1 plus I2, and that will be 1,000 plus 1,100. And that works out to be $2,100. So that'll be answer for part B. And then the third part, which is part C, the amount accrued after 2 years. Amount accrued is always the principal that you started off with plus your total interest. Your total interest will be I1 plus I2. Good? So that would be equal to the principal that you started off with, which is $10,000, plus what are the interests you earned? I1 plus I2 was $2,100. $2,100. So 10,000 plus $2,100 would give you the answer. And that works out to be exactly $12,100. Okay, any questions with that so far? That makes sense? Okay. But everything following there. Okay, so now, are you writing? All right, tell me the truth. Okay, what I want to show you guys is another equation that you could use, right? Just to expose you to it. Because in this situation here, if you were only to be exposed to this equation, and they told you to find the total interest earned after 10 years, what it means, you'd have to do this 10 times, not so? And of course, that will take up quite a bit of time in the exam when your time is limited. So I'll be exposing you to another equation. I'll write it down that you could use. Right? Let's say the question was to find the interest accruing, right? Or to find the amount accruing after the 2 years. Let's say all we had to do was find was C, right? Is there another equation that we could use? And the answer is yes. There is another equation we could use. And the equation is, I'm putting it up on the board now. The equation is amount accruing A is equal to principal times open brackets 1 plus r over 100 to the power of n. Right? That would be the equation that I'd want you to be aware of. A is amount accruing, P is principal, R is rate, and N is the same thing as T, is the amount of time in years. Right, so how would we apply this? We would say that the amount accruing in this situation would be the principal, 10,000, into 1 plus R over 100, which would be 10 over 100, to the power of n. In this case, n is the number of years, just like t was, so it'd be 2 on top of here. So you'd have to be able to work that out, right? You guys have to be able to work that out on your calculators. So how would we work that out? Not a problem. First step, amount accruing will be 10,000. 1 plus 10 over 100 is 1 plus 10 over 100 is 0.1. If you divide it, you'll get 0.1. So this will work out to be 10,000 into 1.1 to the power of 2, or 1.1 squared. Right? And you could do that easily on your calculator, 1.1 squared. Here's an x squared button, and you multiply that answer by 10,000, and you should get 12,100. Okay? So you get the answer as $12,100, which would be giving you the amount accruing. Now, how you feel about using this equation as opposed to going through that lengthy approach? Was it easier using this equation? Yeah, once you know how to plug it into your calculator, you could get the answer very easily. But this would have its advantages and disadvantages, because you'd have to know how to use your calculator. If this number 2 is 25, you have to know how to plug it in. You'd have to use a function called y to the power of x on your calculator. So you'd punch this in, then you punch the button y to the power of x, and then the number, the power, and you would get the answer. The other disadvantage this equation has, it gives you the amount accruing. So if you had to find the interest at different stages, it will be a little challenging as compared to how we were able to find the interest at each stage here. Okay? Because this just gives you the amount accruing. That's the thing you have to be aware. This gives you the amount accruing after the years, whereas the simple interest equation gives you what the interest is at each stage. Okay? Remember that. That's the difference. Okay? So I want you to write down this, and you'll try to do it for homework. And you'll bring this back in the next class. I'm giving you this question here. And the question says, a man wishes to invest $3,500 A man wishes to invest $3,500. Full stop. He can buy savings bonds. He can buy savings bonds which pay a simple interest, at the rate of 12% per annum, or he can start a savings account, which pays compound interest, at the same rate, Full stop. Calculate the difference the difference in the amount of the investment. Calculate the difference in the amount of the investment at the end of 6 years, at the end of 6 years and 4 months. At the end of 6 years and 4 months. Full stop. State which of the two investments, after the full stop, state which of the two investments is better. State which of the two investments is better. Giving reasons for your answer. Giving reasons for your answer. Okay. Now, in order to do this problem, the first part, that is, they say calculate difference in the amount of the investment at the end of 6 years and 4 months. There are two things you could do. You could find the amount accruing for both investments, right? When it's simple interest and when it's compound interest, and then subtract the two, right? After you find the amount accruing. Or you could find the interest from each investment and compare the two. Remember, of course, that the compound interest formula starts off with A equal to, which is the amount accruing, whereas the simple interest formula starts off with I equal to. So when you're doing your comparison, you have to remember that they're two different equations. And you have to extract the information that you need, right? Either you're dealing with the amount accruing or you're dealing with the interest earned. One or the other, right? After that, you could then state which of the two investments is better by comparing one or the other. What I'd like you to do now is to calculate for me what is from the first investment, which is a simple interest investment. Calculate for me now what is the interest that will be earned from that investment under a simple interest situation, which is the savings bonds which pay a simple interest. Find out for me what is the interest he would earn in that case from the savings bonds. Okay, so we're looking at the two investments. The first one, the first investment, right, which is a simple interest investment. This investment here is really a simple interest investment. Good? That one, we use the formula principal by rate by time over 100, right? Principal by rate by time over 100. The principal was 3,500. The rate was 12% per annum. And the time was 6 years and 4 months converted to years will be 4 divided by 12, right? So it will really be 6 and 4 over 12 divided now by 100. So how do we actually work that out? That's the question, right? That's the challenge. So this is what you'll be punching into your calculator. For this one, you'll be punching 3,500 multiply by 12 multiply, you're punching the number 6. Then you go to your calculator and you look for a button that is marked A and B over C. So this is the button you're looking for. A and B over C. You all seen that button? Right. So when you reach the 6, you press this button A and B over C on the calculator. Then you're going to press the number 4. Then you're going to press the A and B over C button again. And then you're going to press 12. Right? That really creates the fraction. So you're going to press 6. I'm writing it here. When you reach that point, 6. Then A and B over C. 4. That means 6 and 4. Then you press the button again, A and B over C. And then you press 12. Okay? That will give you 6 and 4 over 12. If you wanted, and you cancel it down to 4 into 4, 1, 4 into 12, 3, you could press 6. You press this button, A and B over C, 1, A and B over C, 3. If you had canceled it down. You press equal to, press the equal sign, and then you press divide by 100. Okay? You want to try it? Try it and see if you're getting it now. So, what you press on your calculator is 3,500 multiplied by 6. Then the A and B over C button, not multiply by 6, sorry, multiply by 12. That's multiply by 12. Then multiply by 6. Then you press the A and B over C button, 4, A and B over C, then 12. Okay? So 3,500 by 12 by 6, and so on. You all getting that? And then you divide, when you press, after that you press equal to here, and then you divide by 100. At the end of which you should get 2660. You all getting it? Getting it now? Okay, great. So that's how you actually, those are the buttons you press. What about this one now? We're going to the second investment. In the second investment, which is a compound interest investment, the amount accruing A is equal to the principal times open brackets 1 plus the rate or R over 100, all raised to the power of n. All raised to the power of n. So you substitute in. Your principal is 3,500. Your rate is 12%. And your number of years is 6 years. And 4 over 12 because it was 4 months. Now how do you actually type that into your calculator? Well, it's not a problem. You type in your 3,500 multiply by open brackets, and then before we work that out, what is 1 plus 12 over 100? 1 plus 12 over 100, if we work that out, will be 1 plus 0.12. So this here should really be 1 plus 0.12 or 1.12 raised to the power of 6 and 4 over 12, which is the same thing as 6 and 1/3, because 4 into 4, 1, 4 into 12, 3. And this 3,500 will still be 3,500. Okay? So this is the part that we need to be aware of. So I'm going to put that down on the bottom here. So you have 3,500 multiplied by open brackets. You type in 1.12 close brackets. Then you look for a button. This is the button you're looking for. y to the power of x. Because now you have to raise this 1.12 to a power. So you punch in the button y to the power of x, and now you have to punch in 6 and 1/3. So you punch in 6, and guess what button you're going to go for now to get the 1/3? This one here, the a and b over c. So you punch in a and b over c. So that's 6 and 1/3. So you're pressing the 1 to get the third 1, a and b over c again, and then 3. That's how you're going to get your answer. Then you punch in the equal sign, and you're going to get your answer. The answer you should be getting is $7,174.34. Okay? So when you work that out, you should get $7,174.74, sorry. $7,174.34 if you round it off to the nearest cent. So this would be to the nearest cent. Okay, to the nearest cent. You all getting it? You getting it now? Okay. So you learned some important things, how to use certain buttons on your calculator today. How you're using the fraction button, which is the a and b over c, and how you're using y to the power of x to get your powers. Those are two very important functions that you have to be aware of. Okay? Now, what I want you to find now, having gotten your accrued amount, find for me now what is the interest that you earned in your second investment. Find now for me what is the interest you earned in your second investment. So far, what you have is the amount accruing in your second investment, which is the total that you'll get coming back. Tell me now, what is the interest you would earn in that second investment? Yeah, what I asked you guys to find for me now was the interest earned in the second investment, which actually is a very easy thing. Because the interest earned in the second investment, right, if we just write it below, let's write it below here. Interest earned I could be found from the equation for amount accruing. Let us recall what that is. Amount accruing A is equal to the principal plus the interest. Right? That's what we have to remember. Amount accruing is equal to the principal plus the interest. So if I want to get the interest, all I have to do is from this equation recognize that the amount accruing minus the principal will be equal to the interest. How I get that? Subtract P from the right hand side to get the interest, and therefore I have to subtract it from the left hand side. Normal equation manipulation. So amount accruing minus the principal will be equal to the interest. In this question, the amount accruing we worked out to be 7174.34, not so? And the principal was 3,500. So therefore, we could get the interest by taking the difference of those two numbers. 7174.34 take away $3,500. And that will give us the interest. Right? When you subtract that, you should get 3,674.34. 3,674.34, like that. Okay? And that would be the interest that was earned. That would be the interest that was earned in the second investment. 3,674.34 would be the interest earned in the second investment. Okay, so the difference of the two investments would be 3674.34, which is how much you earned interest from the second investment, take away 2660, which is the interest you had earned from the first investment. Remember, I told you that you'd have to compare the interest or the amount accruing. What I chose to do was compare the interest, and you'd realize that it amounted to 1,014.34. Right? So that would have answered the part that said calculate the difference in the amount of the investment at the end of 6 years and 4 months. That is the difference in the two investments. And state which of the two investments is better. From your observation, which one is the better investment? Is it the first one or the second one? It's the second one. And it's the second one because in the second one you get more interest than in the first one. As a matter of fact, you get $1,014.34 more in the second investment than in the first investment. So you'd have to say that and state which of the two investments is better and why. You write it in. The second investment is better than the first. The second investment is better than the first. Since, what's the reason? The state reason. Since here, the interest is how much higher? It's $1,014.34 higher. $1,014.34 more. Okay? So that's what I mean, and give reasons. So the second investment is better than the first, since here the interest is $1,014.34 more, right, than in the first case. So this one is the better interest. It's a better investment. Right? So that's a very comprehensive question. If you could actually get that, and this question would be worth something like about 12 marks in the exam, 10 to 12 marks. Because you see how much analysis you have to do. Okay? Okay, so you're just taking some notes to close off. And we're looking at percentages. Percentages is the heading. But the major heading is really consumer arithmetic. So the heading above percentages would be consumer arithmetic. All right, consumer arithmetic, and we're looking at percentages first of all, and profit and loss. Profit and loss. Okay, you can start off by writing, all businesses operate to make a profit. All businesses operate to make a profit. Full stop. The profit is equal to the selling price minus the cost price. The profit is equal to the selling price minus the cost price. I'll say it again. All businesses operate to make a profit. Full stop. The profit is equal to the selling price minus the cost price. So based on that, we could come up with a first equation, which is profit P is equal to your selling price minus your cost price. So P is equal to SP minus CP. And we call that equation 1. Profit is equal to selling price minus cost price. And coming out of that, we could get a second equation, which is equation 2, that says that if we want to find the percentage profit, written like percentage profit, percentage P, percentage profit, that would be equal to the profit P over the cost price multiplied by 100. That's the second equation. If you want to find the percentage profit that a business makes, you take the profit divided by the cost price and multiply the answer by 100. Okay? Sometimes in a business you don't make a profit, you make a loss. Right? That is in the cases where your cost price actually is higher than your selling price. So when you sell it, you don't make any profit, you make a loss. And in that case, we could come up with a third equation, which we'll call equation 3. And in that equation, we say that the loss, if you make a loss, it'll be equal to your cost price minus your selling price. If you make a loss, then your loss will be equal to your cost price minus your selling price. And just as in case of a profit, where you can have a percentage profit, you can also have a percentage loss. So a fourth equation, in that context, equation 4 will be percentage loss. Percentage loss would be equal to the loss divided by the cost price multiplied by 100. The loss divided by the cost price multiplied by 100. Okay, so let's look at an example. You write down the example. Example 1. A shopkeeper buys 25 cricket balls at a total cost of $150. At a total cost of $150. A shopkeeper buys 25 cricket balls at a total cost of $150. A, if he sells them at $8 each, if he sells them at $8 each, what was his percentage profit? If he sells them at $8 each, what was his percentage profit? B, if he sells them at $5 each, what was his percentage loss? B, if he sells them at $5 each, what was his percentage loss? Okay? All right. Well, let us first find his selling price. Because if we find his selling price and we know his cost price, then we could find his profit. And then from there, we could find his percentage profit. So let us find his selling price first. His selling price, which we'll call SP, will be equal to the price he sold one ball for, which was $8, times the number of balls that he sold, which was 25 balls, 25 cricket balls. So it means that his total selling price in this case was $200. We know that his cost price, because it told us his total cost price, was $150. Therefore, we could find his profit, because we know profit is equal to, from equation 1, selling price minus cost price. So we could work out what his profit is. We'd say $200 minus $150. And we'd get the answer for his profit, which worked out to be $50. So if we know what his profit is, we could find his percentage profit. Therefore, his percentage profit, the equation for his percentage profit is, from equation 2, profit divided by cost price multiplied by 100. So to get his percentage profit, we take the profit we got, which is $50, divided by his cost price, which in this case was $150, and multiply that answer by 100 to get his percentage profit. Okay? And when you work that out, you get a profit of 33.33%. Okay? Notice I didn't round it off to 0.333 or anything like that. I kept the fraction, because the fraction would give the actual totally correct answer. Okay, so that would be the answer. What we just worked out was the answer for part A. What was his percentage profit? Then we do part B. Right, we did what was his percentage profit? 33.33%. Then we'll do part B. In part B, they say if he sells them at $5 each, what was his percentage loss? So if he sells them at $5 each, we could get his selling price by saying each one costs $5 multiplied by 25 of them, 25 cricket balls, and that gives us a total of $125 as his selling price. We know what his cost price was from before. His cost price still was $150. We can't change that. That's how much it was. His cost price still was $150. So therefore, if you observe, his cost price now is $150, which is higher than his selling price of $125. So in this case, he's going to make a loss. Right? So we could work out what his loss would be. And his loss would be his cost price minus his selling price, which would be equal to $150 minus his selling price, which is $125. Okay, 150 minus 125. It means that he made a loss of $25. $25 was his loss. Therefore, his percentage loss, which is what they're asking us to find in part B, we go back to the equation, percentage loss, which is here, which is loss over cost price times 100. Loss over cost price times 100. And if we work that out, his loss would be $25 over his cost price, which was $150. And we multiply that answer by 100. Okay? And that would give us what we are looking for. And you end up with an answer of 16 2/3%. 16 2/3%. Okay, so we'll close off with that today. What I need to do is give you the homework. The homework would be the chapter that deals with compound interest, right? So that would be, we'd look at exercise 52, which would deal with compound interest. You would leave out any question that deals with compound interest tables. Leave out that one, exercise 52. Don't do any of those that have compound interest tables on it. And then when we come back, we will continue with the percentage, profit and loss, and all the other consumer arithmetic questions. All right, so that exercise was exercise what? 52, was it? Exercise 52. We do all the questions there. Right, you do the questions except those with the tables. Okay. Okay, is there anybody who didn't collect the card from outside? Anybody? All right, so you'd have to go for your card for me.